All right, rationalizing. It turns out values like this that have a root in them can be written a couple of different ways. In one way, they end up with a root in the denominator. The other way, they end up with a root in the numerator. Which one is correct? Technically both. They represent the same number. There's nothing really wrong with either one of them. But it would drive us a little nuts if every one of our answers had two separate versions and you had to work with both of them. So the mathematicians of the world have pretty much just made up a rule and said, everyone please do it this way so that our work all looks the same. And the rule is, thou shalt not put roots in a denominator if thou canst help it. So if you have 1 over root 13, no good. You'd get red ink if you gave an answer like this. The way you fix it is you multiply the top and bottom of that expression by root 13 again. Right? You can always multiply a fraction by anything you like as long as you do it to the top and the bottom. So you do that and you get root 13 over, well, I could say the square root of 169, but you know what's going to happen after that. It becomes just 13. This is the preferred answer. Yeah, it's maybe a little more complex than the 1 over root 13, but overall this is going to save us grief, because if we all do it this way, our answers will all come out the same, and that's nice. In B, root 5 over root 2, again, we have a root in the denominator and we don't want it there, so multiply that by root 2, multiply upstairs by root 2. And what happens? Well, upstairs, root 5 times root 2 is root 10. Downstairs, root 2 times root 2 makes root 4, which is just plain old 2. That's your rationalized answer. Notice in this case, we actually get a small cleanup benefit where the original expression had 2 roots in it, we only have 1. That happens reasonably often. C, root 2 over minus root 6. If we multiply the bottom by minus root 6 and upstairs by minus root 6, what happens? You get minus root 12 over negative times negative becomes positive. Root 6 times root 6 is 6. Why shouldn't we stop there? I hope you noticed that root 12 is reducible. We're not going to remind you about that. We're going to just start assuming that you will do that, or expecting that you will do that. You will always break down roots whenever possible. So you get minus 2 root 3 over 6. Divide the top and bottom by 2 to reduce the fraction, and you get minus root 3 over 3. That's that one cleaned up. And finally, root 20 over root 3. Multiply by the denominator root that you don't want, and you get root 60 over root 9, which is just 3. We don't stop, because root 60 is root 4 root 15, which is 2 root 15 over 3. That's the most we can clean that one up.